Hey, welcome to the last day of chapter 3. It's felt like a little bit of a longer chapter, I know, but that's because we've really taken our time. We've had some breaks, including delicious Thanksgiving. Don't forget that we'll be reviewing these next couple days. We're going to review on Wednesday and Thursday. And your review is actually a part of this packet. We see we've got our review right here. For me, it's on page 33, but that's part of this. And then we're going to have our quiz over days 5 through 8 on Friday. So keep that in mind, guys. That's kind of what we can look forward to for the rest of the week. We're going to do our last day of chapter 3 today. Review on Wednesday and Thursday, and then quiz on Friday. So let's get into our last day here. What are we talking about? Well, something a little different. We don't have a new form. We're done with forms of lines. Instead, we're going to be focusing today on applying the idea of slope when it comes to parallel and perpendicular lines. And so let's get our brains thinking here a little bit. I want to see what you guys can come up with when it comes to these two in particular. Go ahead and list some things that maybe we know about parallel lines and perpendicular lines. And then give me some room to where you can write out maybe what I have to add as well. Let's go ahead and try. You can pause. Okay. So parallel lines. We know these are lines that maybe look like that, or maybe like that. In other words, they don't what? They don't touch. Yeah, parallel lines are lines that run beside each other but never touch. How about perpendicular lines? Now, some of you guys probably said, well, these are lines that intersect, right? They cross each other. And that's true. But here's the thing. They cross to form 90-degree angles. What do I mean by that? Well, if I were to draw, let's say this, and these were perpendicular, that would mean they hit where this is a right angle, this is a right angle, this is a right angle, and that's a right angle. It forms 4 right angles. So intersection, where 4 right angles are formed. Very specific here. So parallel lines, they are lines that never touch. Perpendicular lines are lines that cross to form 90-degree angles. So what does this have to do with slope? How does slope relate to both of these? Well, when it comes to parallel, my marker's running low. Let me see if I can rewrite that. This one's running low too, man. You gotta give me some more markers. When it comes to parallel lines, why do you think they never cross? Why do they never intersect? Well, that's because M is the same. In other words, they have the same slope. These two lines have the same slope. They go with the same trajectory. That's why they never intersect. Now, for perpendicular, it's a little bit different. Perpendicular lines are different. And this is a little bit trickier. They have what's called opposite reciprocal slopes. So we know they intersect in a very particular way where they form 4 right angles. And the reason that happens is they have opposite reciprocal slopes. That word opposite, that means, if you want to break this down, that means different sign. So if one's positive, one's negative. And reciprocal, we know that means flipped fraction. A reciprocal is a flipped fraction. So in other words, if you have 1 over 3, the other would be 3 over 1. You see that? So they have different signs and they're flipped fractions of each other. That's why one goes one way and one goes the other way. Okay. So for example, let's say I had a slope that was, let's say one of my lines was positive 2 over 3. What would the other line need to be if these were going to be perpendicular? Well, first, it has a different sign. So if that's positive, ours would be negative. And then flip the fraction. So if that's 2 over 3, flip it to be 3 over 2. So these two would be perpendicular. See that? See that? That would be perpendicular slopes right there. So that's what we're talking about. So let's do a quick reminder, guys. What do our two previous forms, the first two we talked about, look like? Let's go back to, these were the forms that actually involved slope. We know standard form didn't really involve slope. So go ahead and take a chance to write these two for me. Y equals mx plus b, and y minus y1 equals, I don't know how I keep grabbing the wrong marker, m times x minus x1, where we know m is our slope and b is the y-intercept. It's where your line hits the y-axis. It's a point. And with point slope, we know that they give you a random point, x1, y1. That could be any point on the line. And they give you, of course, the slope. We can get that from the name. Okay. So let's get some practice in here with these concepts and parallel and perpendicular. So, what is an equation in slope-intercept form of the line? So again, we're looking for y equals mx plus b eventually. Now, we may not be able to start there. Of a line that passes through 215. Okay, so our line passes through that point. Wait a minute, that's an x1 and a y1 they just gave us, a point, and is parallel to this graph right here. So our line is going to be parallel to this line. So what do we know about our line that we're creating? Well, we know it's going through the points 215. That's a point on our line. We also know that the slope is parallel. Wait a minute. Parallel means same slope. Remember that? So what's the slope of this one? Y equals mx plus b. Oh, the slope of this is 4, which means if our line is parallel to that, it has the same slope, so our slope is going to be 4. Hey! And so, guys, we have a point and we have a slope. Which form do you think we should use? Which one? Probably point-slope form. So, we're going to go y minus y1. So, y minus y1 we said is 15 equals m. We said our slope is 4, parentheses x minus x1, which is 2. And so here is our line, guys. Here's an equation of our line. The problem is they want this in slope-intercept form, which we have not gotten to yet. We need to get this, which is in point-slope form, to slope-intercept. But it's always 2 steps. Very, very straightforward. It's always 2 steps to get there. First, distribute. We got 4. Let's multiply that to both x and the negative 2. So 4 times x is 4x. 4 times negative 2 is negative 8. Y minus 15 still chilling over here. Okay, hey, we're close. We just need to get y by itself. Right now, y has a minus 15 next to it. So step 2, get y alone. So if it's y minus 15, couldn't we add 15 over? Yeah, so add 15 over, cancels. You get y equals 4x. Negative 8 plus 15 would be positive 7 plus 7. And so that is what we were looking for right there. Y equals 4x plus 7. Great job, guys. Fantastic job. So what I'm going to let you guys do is I'm going to let you guys try number 2. But first, I want to help you at least make sure you've got the setup here. So once again, we need to write an equation of a line that passes through. We will give you a point, x1, y1. So I'm thinking our line probably going to need to start in point slope form. Probably what I'm thinking here, but we're going to need to work it into slope-intercept form eventually. So we know our line passes through the points 10, 15. That's our x1, that's our y1. Now how about the slope? Now we're told our slope is going to be perpendicular. And if you remember, perpendicular slopes are opposite reciprocals. They have a different sign from each other and they're flipped. So what's the slope of the line that we're perpendicular to? Well, here's another line. Again, they give you another line. And its slope is negative 5 over 6. Now, our slope is opposite reciprocal of that. So in other words, if this is a negative, our slope is going to be a positive. And if it's 5 over 6, our slope is going to be 6 over 5. And so I'm going to let you guys see if you can create the equation and then work it down into slope-intercept form. Go ahead, guys. Give me your best shot. See if you can finish. All right, guys. So first, we probably need to start in point slope form since we don't actually have the y-intercept. So we've got y minus our y1, 15, equals our slope, positive 6 over 5, and then parentheses x minus x1, which is 10. Okay, so this is point slope, but we want this in slope-intercept. So don't forget our 2 steps. Distributes and get y alone. Okay, so we'll distribute first. So y minus 15 equals 6 over 5 times x will just be 6 over 5x. And then 6 over 5 times negative 10, remember, that negative 10 is multiplied to 6. What's negative 10? Check it out. Negative 10 times 6. That would be negative 60. And the negative 60 is over 5. So negative 60 divided by 5. Oh, so this times that is really just negative 12. And then last step, get y alone. We got a minus 15 over here, kind of like we did on the last one. That's complete coincidence. So we add 15 over, and you get y equals 6 over 5x. Negative 12 plus 15 is positive 3. And there you go. There's slope-intercept form right there. Great job, guys. Excellent work. So let's finish up this page with a quick one. This one's going to be a heck of a lot quicker. We just did 2 of the toughest problems right now. So are the 2 graphs, so the equation of this line and the equation of this line, are they parallel, perpendicular, or neither? Well, right now we can see this is in slope-intercept form. So we know the slope is 2/3. Well, to know if it's parallel, perpendicular, or neither, it's all based off the slope. The problem is, this one's not written in slope-intercept form, but it could be if we get y alone. Check it out. What's beside y right now? A 2. So if this is 2 times y, we're going to divide by 2. That'll get y by itself. The problem is you also have to divide that by 2 and divide that by 2. So negative 3 divided by 2 gives you negative 3 over 2. And then plus 6 divided by 2 would be 3. So here is this equation written in slope-intercept form. What would its slope be? Looks like negative 3 over 2. So here are our two slopes. Are they parallel, perpendicular, or neither? Well, they're not the same slope, so it can't be parallel. Are they opposite reciprocal slopes for perpendicular? Different signs and flipped. Let's see. Positive 2/3, negative 3 over 2. Ooh, these are perpendicular lines. They're doing this action right there. Yeah, we got some perpendicular lines. They are intersecting to form 4 90-degree right angles. All right, on to the last page, guys. If I can turn the page, that is. Here we go. Now, here's what I'm going to do. This next section, the top half of this next section, guys, is going to be a little bit different. So the top half of this page is practice. It is practice from the previous page. Check it out. Same exact thing. We're going to write an equation, slope-intercept form, when we know that our line is parallel to the given line. So in other words, 1 and 2 are the exact same as this first problem we did on the previous page. So what I'm going to have you guys do is I'm going to have you guys try number 1 for me. Then, check out down here. Determine whether the graphs of these are parallel, perpendicular, or neither. Well, that's just like the problem we literally just did. And so what I'm going to let you guys do there is I'm going to let you guys try. Let's actually go 1, 2, and 3. We're going to try all 3. And a little secret, for this one, we know this is in y equals mx plus b, which is great. We can tell the slope. This one is actually written in standard form. You can't tell the slope, but you want to put this into that form. So in other words, you want to get y by itself. So you can have slope-intercept form and be able to tell these two. So I'm going to let you guys actually try number 1 and then number 1, 2, and 3. And then we'll finish up with some final problems here. Remember, on these, you're just telling me whether the graphs are parallel, perpendicular, or neither. This one, you're going to have to write an equation for our line that is in slope-intercept form, that is parallel, and goes through that point. So go ahead, guys, give me your best shot. All right, let's see how you guys did on this first one. So parallel means that whatever the slope of this line is, our line will also have the same slope. Slope of 2 over 1, so our line has a slope of 2. We pass through the point negative 1, 3. That's our x1, y1. So if they give you a point and a slope, probably a good idea to start off in point-slope form. So y minus y1, y minus 3 equals our slope, 2. Parentheses, x minus x1, but x1 is a negative 1. So x minus negative 1, really, when you subtract the negative, doesn't that become a plus? So x plus 1. Now, we want to write this in slope-intercept form. We know that's y equals mx plus b. So we need to get the y by itself. So first step, distribute. We got to simplify this. So 2 times x is 2x, 2 times 1 is 2, and then get y alone. So if there's y minus 3, add 3. So y equals 2x plus 2 plus 3 is 5. So the toughest problem is knocked out right there, guys. Now, for these next 3, they wanted you to determine whether these lines were parallel, perpendicular, or neither. So this one, we already knew the slope. Slope of this one is negative 5. The problem is we can't tell the slope of this yet, but if we subtract 5x over, Obviously, negative 5x and negative 21 don't go together, so we set them beside each other. That gets y by itself. You have y equals mx plus b. So the slope of this is, it's also negative 5. These are the same slope. And if they have the same slope, they are parallel lines. Now, number 2, this is kind of a fun one. X equals 1 over 10. Oh, wait a minute. X equals a number. That creates a vertical line. In other words, slope is a number over 0, because we know we're dividing by 0. It's undefined. Y equals 1/10. That creates a horizontal line, which we know has a slope of 0. Which we know has a slope of 0 over a number. Sorry about that. Yep. Wait a minute. These are perpendicular. They intersect perfectly. So we got some perpendicular lines there. And then finally, hey, these are both written in. Y equals mx plus b. We love to see it. Here's the slope, 6 over 7. Here's the slope of this one, negative 6 over 7. So they're not the same. So not parallel, but they're also not reciprocals of each other. Not flipped. So they're not reciprocals. They're not perpendicular. This is going to be neither. These are just two random lines that are going to intersect each other, but not form 490-degree angles. Okay. So last thing for today, guys. I want you guys to try. Let's try number 2 here. This time, exact same thing as what we were doing up top, except now it's not parallel. It's going to be perpendicular. And then, before you guys try that, I want you to just give me your best shot as far as what you're thinking on number 1 and number 3 down here as well. So let's see what you guys can do with these 3 problems right here. And again, just make sure you know that because our line is perpendicular to this line, we know we got to flip that 1/2 and make it the opposite sign, so negative. So our slope is going to be negative 2 over 1. So just giving you a heads up there. All right, so let's check these real quick, guys, and we'll be done, almost done for the day. So we know our line's passing through 2, 7. So that's our x1, y1. If that slope is 1 over 2, then if our line is perpendicular to it, we flip that fraction and change it. So negative 2 over 1, which is really just negative 2. So then y minus y1, which is 7, equals our slope, negative 2, times x minus x1, which is 2. Then, if we want to put this into slope-intercept form, we do our 2 steps, distribute, and then get y by itself. So there is our line that is perpendicular to this line and passes through that point. Now, as far as number 1, what is the slope of a line that is parallel to this line? Well, y equals a number. Anytime you see that, that's going to be a horizontal line. We know horizontal lines have a slope of 0. So what is the slope of a line parallel to a horizontal line? It'd be the same slope. So 0. Now for number 3, what is the slope of a line that is parallel? So same slope, 2, x equals negative 4. Now x equals a number, that's going to give you a vertical line. And we know the slope of a vertical line is undefined. So then, same slope. The slope of a line that is parallel to that would also be undefined. So, obviously, just for funsies, number 2, last one here. What is the slope of a line that is perpendicular? So opposite reciprocal to y equals 2. Well, just like we said, horizontal line, slope is 0 over a number. Flip that, it would be a number divided by 0, which you cannot do. So a slope that would be perpendicular to a horizontal line, slope of 0, would be undefined. All right, guys, so look forward to our review. Don't forget, we got a quiz this Friday. And I'll be talking to you soon. Have a great day.